The synapse is a point of contact between neurons where information is transferred and interpreted. The axon of the presynaptic neuron ends in a button-like ending on dendrites of postsynaptic neurons. The presynaptic neuron is separated from the postsynaptic neuron by a space called the synaptic cleft. Within the terminal of the presynaptic neuron are vesicles containing neurotransmitter chemicals. In this illustration, the chemical is acetylcholine, a common neurotransmitter in the nervous systems of both insects and vertebrates. The membrane of the postsynaptic neuron next to the synaptic cleft is differentiated and contains ion channels that are regulated by the neurotransmitter chemicals released from the presynaptic neuron. The postsynaptic ion channels have a receptor site that binds the neurotransmitter chemical from the presynaptic neuron. Information comes into the synapse as a frequency of action potentials in the presynaptic axon. Depolarization of the neuron membrane by the action potentials opens calcium channels and allows calcium entry into the presynaptic terminal. The calcium ions assist in the migration and fusion of the synaptic vesicles within the membrane of the presynaptic neuron. Fusion of the synaptic vesicles with the membrane releases the neurotransmitter chemicals into the synaptic cleft. The number of vesicles that release neurotransmitters is proportional to the number of incoming action potentials. The released neurotransmitter chemical diffuses across the synaptic cleft and binds with its receptor on the ion channel of the postsynaptic membrane. Receptor binding of the neurotransmitter chemical causes the ion channels to open. Cations such as sodium flow along their electrochemical gradient from the synaptic cleft through the open ion channels and into the synaptic neuron and cause a localized reversal of the electrical charge of the postsynaptic membrane. If the depolarization of the postsynaptic membrane is sufficiently great, it will stimulate a new frequency of action potentials to form in the postsynaptic neuron. The acetylcholine neurotransmitter chemical is degraded by a cholinesterase enzyme located in the synapse. Cleavage of the acetylcholine causes the ion channels to close. The synaptic membrane of the postsynaptic neuron then returns to its resting membrane potential. We will now explain how information is interpreted by the synapse.